due, I'm going to hand you over to Sam Guckenheimer. Sam is the product owner for Visual Studio Team Services, which is probably one of my favorite teams at Microsoft at the moment. The rate they are shipping new features in VSTS is absolutely amazing. Great release cadence, lots of new features coming all the time. If you want to talk VSTS and get some of your favorite feature ideas, go and talk to Sam after the presentation. But here he's going to tell the story about how Microsoft moved their teams to a DevOps model and into the cloud with VSTS. Thanks, Sam.
Thank you, Stephen. Thank you all for having me. London is looking great relative to when I lived here decades ago. And thank you, Jeffrey, for doing a great job advertising the talk I'm not going to give. So this isn't going to be why DevOps is about validated learning. I'll be happy to talk to you about that. But the talk that I agreed with Stephen for this conference was to give you a look at how we, Microsoft, have moved our own engineering at scale into DevOps, into the public cloud, and what that looks like for you. So if you don't know me, I've written a few books. I've been at Microsoft 14 years. I came from the now defunct Rational Software Company. I run a site called DevOps at Microsoft and a few other things these days. So my story starts with the way Microsoft once was. For 20-some years, Microsoft had a policy that every one of the divisions, Windows, Office, blah, 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 would run its own engineering system. And the rationale for this was that, hey, if we do our own thing, we can go faster, we can, everyone can do what they need, and they'll get more done, and so on and so forth. That was the theory. The practice was, when everyone was running their own engineering systems, everyone had more cruft, they had more duplication, they had more impedance, and they all went slower. And this would show up in things like our annual employee survey, where we ask, how happy are you with your engineering system? And it would show up in the appeal of, the rest of the world's, moving so much faster than us. And one of the biggest consequences of this idea of everyone does their own thing was an internal culture in which no reuse would go unpunished. Or, as I was taught in my, probably second week there, take no dependencies. You could not expect anyone else to deliver what you wanted. You had to do it all yourself, so you better do it over again. And out of that, we had 300 XML parsers, probably 61 versions of jQuery in production, many of everything. So about 3 years ago, with new leadership under Satya, there was a decision to reverse that policy, to say, hey, we want to have one engineering system. We want it to be world-class. We want the best engineers working on the best engineering system to provide the best productivity improvement for ourselves inside Microsoft, and that we will take outside to customers so we can deliver that for customers' use too. That's what we make available to you as Visual Studio Team Services. It's a SaaS hosted on Azure. It is the same code base as Team Foundation Server, but it's delivered continuously, and we develop cloud first. How many of you use VSTS, know VSTS? Great, okay, so about maybe a third of the room, something like that. Anyone using TFS? Okay, so a smaller group, fine. So a lot of what I'm going to show you is going to be reasonably familiar, but I'll show you how we use it. Now, in doing this, we went all in on Git. we said that we want to make sure all the source in the company is available to everyone, that any dev anywhere can offer improvements for everyone else, that company IP was company IP that was reusable, that anyone could find components for reuse, that devs would be rewarded for the assist, not just for reinventing stuff, that the impedance from making a change to seeing it in production would be proportional to the change made, not to the complexity of the cruft that was needed to get it into production. And similarly, that build and test would be proportional to the amount of the change. And really importantly, as a culture in a big organization, we wanted to provide horizontal mobility. So we didn't want people to get into the situation where they wanted to move jobs and someone said, you only know how they work over there. Everyone works the same way. So rather than spend a lot of time in slides, I thought I would spend most of my time showing you part of a day in the life of. Okay, obviously, it's not going to be a full day. You have other sessions to go to, but I'll just give you a little bit. Okay, so I'm logged in live. So I'm not quite sure what you're going to see or what I'm going to see, but we'll do our best. Okay, so I'm right here under mseng.visualstudio.com, which is our instance of Visual Studio Team Services. Oh, that was a little too fast, that click. And before I go there, I just wanted you to see these two widgets are showing us, VSO.pr is showing us the pull request sequence on the VSO project, which was the original name of VSTS, and the lower one, .ci, is showing us continuous integration. So the idea is that all your code, as a developer, has to go to master, single master branch, and it gets there by means of you're making a pull request. No pushes. It goes through a pull request, and the pull request has a defined process. That process, I'll show you. So, and if you notice, by the way, because we're using pull requests at the beginning, we've got a bunch of failures here, which is fine, okay? The idea is to shift left and get the failures early. So let's take a look at what it means to have a pull request build. So this is the build summary on the most recently completed pull request. That was 97 seconds ago. It ran 60,356 tests. It ran those in a matter of a few minutes. The whole pull request took 26 minutes. The test probably took about 7 minutes of that. Okay. Now, if one of them failed, if one of the 60,000 failed, the pull request would have failed there. Okay, so, and to get, let me give you a feeling of the frequency of these. Again, this is live, so I'm not quite sure what I'm going to see. There are only 2 in progress now. If I look at history, you'll see this is about the last 40 minutes. And this is a slow time of day. The US hasn't woken up yet. Okay, so let's look further at what that pull request means. So the pull request that triggered that build has to go through that build process that runs those tests that I just showed you. They all have to pass. There's a security test that has to pass. And if you read closely, I don't know if you can see this in the back, it says those expire in 12 hours. Why? Because a reviewer needs to approve. Right now, this isn't going further because no one's approved yet. I can see the full history here. But someone needs to approve this now, and they need to approve it in 12 hours, or the pull request submitter needs to submit again so that the code is always fresh. Okay, we want to be very careful not to get into merge conflicts, so we queue these up sequentially. And as a reviewer, I can look at what exactly are the file changes, and I'm looking at a couple lines of change, or lines there, file added, and one new include. Okay, so that's the kind of change we're talking about. Again, all the code goes through, and every change of code goes through pull request, which requires an approval. So when Conan talked about the regulatory changes and the impact of those, we certainly feel that. We go through ISO, we go through SOC, we go through all the audits, and those require all code be approved, and the 4 I's and separation of duties, blah, blah, blah. We do that by keeping this history of who approves, and the code review works because it's done in these tiny branches, these tiny pull requests, these tiny increments. Okay, so if I look at that as the pull request flow, and I look at this again overall, you'll see that we're averaging about 25% rejection rate on the pull requests, 1 in 4. Good, okay? We want those failures to come early. If I go back to my dashboard, which I was looking at, so you'll see, a bunch of red bars here, and for each one, how long they run. But for continuous integration, you'll see the last 20 or so are running green. And indeed, if I click into this and kind of look at the success rate, you'll see we have under 1% rejection. So prior to code getting committed to master, we're testing it. We're testing it at a high volume. We set a threshold on that testing. The tests need to complete in under 7 minutes. We're now doing about 60,000, as you saw. And that's catching the failures before code gets to master and before continuous integration from master. The next thing that happens after continuous integration is that code now goes through a further set of tests. In the pull request, we were doing what we call L0 and L1 tests against the binary dependencies, like, say, the database. Now we do tests in a pre-production environment, which includes the binary, the dependencies, and test data, like fake identities. And here, we break the tests up into suites, which is what these rows are for parallelization. And you can see up here, each CI build is going through a test sequence. And most of them are green, and the goal is to get 100% green, or you don't go further into production. Let me just show you what a failure looks like. So if a test fails, it fails the suite. And if the suite fails, you'll see here one test out of, make that bigger for you, one test out of 948. And with that, we get the error. Sorry, didn't mean to scroll that. We get the error and the stack trace and a log, server log attached, and if necessary, any bugs that will get filed as a result of that test failure. Okay, that's all done with automation. Okay, and the bug shows you everything that happened, and you can see, again, the full development history, and go back and see all of the integration steps from the original pull request, and again, everything is reviewed. So we are running this at scale continuously. We are using the pull request to shift left, keep code clean before continuous integration, post continuous integration. So we get down to, so, and you can think, this is, you can think of this project as being, by the way, round numbers 500 people, okay? 500 engineers going into this master. If we were looking at Windows, it would be, 6 or more times that in a master branch, whatever. And then after continuous integration, we have these pre-production tests. They all need to run. And then from there, we go on to deployment. So once everything passes, once everything passes, we go into deployment. You see these production updates. Let's take a look at that in a little more detail. So the updates, you can see there were a couple 20 hours ago. There were 4 on Tuesday, 2 on Monday, and what have you. The canonical case is what you see here with 851. It's going across these 6 columns. Those 6 columns are what we call deployment rings. Ring 0 is our canary. That's where we work. So I am right now connected to ring 0. Happens to be hosted in Western US, and this is going through, the web to there. Ring 1, the next column, is the data center with the smallest external user population. So these are paying customers who are connected to ring 1, but this is the data center with the smallest count of them. Ring 2 is the data center with the largest user population. Ring 3 consists of 2 data centers with the highest latency to reach, like Australia and Western Europe. So we go progressively through those, and then when those have all passed, run green, the deployment keeps going to all the rest. Now we will speed things up often, like you see in 874 and 5 on the top here, where we'll do if we're doing a hotfix, we'll accelerate it by splitting it into 2 streams, or we will slow things down by putting an approval wait on a particular deployment. And if there's a failure, as you see here in ring 3, it's not a big deal because it's a 24/7/365 service. There is a version that is there, that is running, that is maybe a day old. And when the update comes through and runs, what it does is account by account, it will update the replica and then swap the replica that was updated to master and take the new replica, which was the old master, and update that. So there's no downtime. No downtime for the user. We don't do downtime. Okay, and for any of these releases, I can in real time see what all the logs are, see what's going on. I can troubleshoot directly in the particular instances. So I can this right now has deployed, but I can go through and review everything that happened on the particular instance at the time and understand what was going on. If there's a failure, understand exactly what's happening. Okay, so that's a top-down view, if you will, of the whole service. Let's talk about what it looks like to be a team from the bottom up. So let me just close some of these things I was looking at. Actually, let me take a slight detour. I mentioned that we're all in on Git. One of the benefits of using Git is that the key benefit is we do get to have everyone in one master branch. So unlike the past, where you had this very feathery branch structure, and the idea of working in isolation was, hey, I'm doing something new, I'll come back in 2 months, we can merge then, and I'll break you for the next month. The branches are as short-lived as the work items. You pick up a work item, you pick up a user story, you pick up a bug, you pick up a task, you click create topic branch. That branch lives while you're doing those changes, and then it's squash merged when the commit happens, so the branch goes away. So you end up seeing this very long, narrow branching structure instead of the wide, feathery one of the past. Okay. So what does it mean to be a team? We work in a structure where organizationally we organize as feature crews. Think of a feature crew as typically 10 or 12 engineers. Here you see the team members on this particular crew, which is called Modern Wit. And they track on their dashboard for their team how many active bugs they have, good idea, the priority. DTS trend right here is customer support issues. They track the cumulative flow of their stories completion. So in other words, over many sprints, how good are they at going from new to done across their stories. And there's this very nice little lean line of work in process. And they also track on the bottom things like lead time and cycle time. Now, the thing they look at probably the most on a daily basis is their Kanban board. So I'm sure most of you get the idea of Kanban boards. So we have here, if I go to the top, come on, or let me shrink this back down. You'll see, I don't know if you can read these columns labeled product backlog, stuff that hasn't been committed to, sprint backlog, the stuff we're planning to do this sprint. We're now in sprint 124. They're 3 weeks long. Active work, what's actually being worked on right now. Review, as I mentioned, everything needs to go through review. Bug bash, which is the internal, we'll test this before we call it done. And then done here is deployed. So you'll also see, it's a little subtle in this size, you'll see that there is a swim lane. So if you notice right there in gray, it says DRI. DRI means designated responsible individual. This is the role of the engineer who's currently on call. So as a development engineer, you can expect that roughly a week per quarter, you will do a rotation as DRI. And that means you handle live site. Handling live site means that if there's a live site incident, an LSI, you're on the bridge within 5 minutes, if it's work hours, within 15 minutes outside of work hours. So it's a you build it, you run it culture. And it's not just the immediate engineers on the team, by the way, in live site. I was in Bangalore Saturday morning at 7 a.m. and got pulled into a live site bridge because it involved one of the customers for whom I am the champ. And since I know the customer best, they wanted context on what was going on, and because I am a champ for that customer, as we encourage the members of the team to be, I could say, I think I know who the right person to reach out to is, and I thought 7 a.m. Bangalore, it's 9:30 in the evening in Houston. Let me contact this guy, and I Skyped him and said, can you talk? And we see stuff going on with your account, and I joined him to the bridge while we were troubleshooting so we could get the customer perspective on what we were observing from telemetry about heavy usage. And sure enough, they had started a batch job with admin privileges, turning warnings off, and it was doing destructive stuff to their data, and we needed to stop it and recover. So that's LSI, and you'll see those little blue tags that say LSI work. Okay, so that's one swim lane. Now, as we go down, you'll see other swim lanes for planned work. Like here you see REST, meaning work on the REST APIs. And you'll see just two things in the active column, right? Because we try to keep work in process clean. And if we go further down, you'll see process migration, one bug in the active column, several things on review. Another one for rules and so forth, one in the active column. And that's how we keep control of work in process. And you may be able to see up here on top, there are WIP limits, work in process limits. So we're 12 of 12 on active work. We're 6 of 8 on things to review and so forth. So they're running just at what they think is optimal for their piece flow. Now that is a great view from the standpoint of the individual crew. It lets you really drill into the work, and of course for each of those you can click from the work to the history to the code and so forth. Let's look up a little bit and see what it looks like if we want to get an overview of the whole thing. So let me take you to plans. So the idea of plans is that now that crew, which I was just looking at, modern wit, collapses to a row. And this is at an aggregate level, not of tasks and stories and bugs, but of features. And I have a note for today. If you notice, we plan ahead typically 3 sprints or maybe 3 and a little more, but not beyond that, by design. Okay? Plans get stale. Requirements are perishable. So we want to just do just enough planning to be able to coordinate, but not so much that we have to revise them. And I can see back before today to what happened before, and I can of course expand and say, okay, what are the details of what each of those crews are doing? So the epic owner will typically look at things in this view to get the overview, and this is the view at which we'll coordinate. Okay. That's a sort of day in the life of, or a few minutes in the life of one of our crews. Actually, I'm going to pause right there and see if anyone wants to ask me questions about that. Go ahead, in the back.
I was just wondering, when do you say
The question is, you submit a PR, it doesn't get an approval within 12 hours, so it expires. Do you have to remerge from master to retest yourself before you resubmit? No one enforces that you have to remerge. It's probably a good idea. Because your next PR will not go through if there's a merge conflict. So we don't make a process rule about that. The process rule is you need to make a PR and it needs to go through the branch policies on that PR, and that includes that it, of course, compiles, passes all the tests, and security and approval. The automation is what counts here. So Jeffrey talked about, well, it's not people in process without tools. There's a virtuous cycle reinforcing process with automation. Over here.
I see you have Kanban Board and then sprint within it. So what is your sprint duration and how does Kanban fit in the sprint?
What's the sprint duration? How does Kanban fit in? So we work in 3-week sprints. It's now sprint 124. So we started counting. We reset the metronome to 1 into 2010. We'd begun this before. It's 124 here in the UK, in Raleigh, in Redmond, in Hyderabad. That is 3 Monday to Fridays, and we start deploying within the sprint. How does Kanban fit in? So you can think of the sprint as a release train. So if I look at, if I go back to my browser and look at the page called Features Timeline, what you will see is that we publish on a sprintly basis both what we have done and what we're planning. So if I go down this page, you'll see our last sprintly release was September 15th. Here is what went in it. On the right-hand side, you'll see when it is planned for the TFS on-prem release. So these things are in TFS 2018 RC1, which is currently available. Others not yet. And if I go back, I can see what went into which one. And then you'll see our backlog and roughly what's planned for when in our backlog on top of this. So the sprint acts as a release train. The Kanban board acts as a daily or intraday view of the work in process. So what the team tries to do with the Kanban board is effectively get to single piece flow, item to item, but the sprint is a boundary at which we plan and deliver work. Did that make sense? Okay, great. Go ahead.
How do you keep the quality of code review high, not just a tick in the box?
How do we keep the quality of code review high? By doing it in tiny batches, every pull request. So a pull request is typically a few lines, maybe 20 lines, maybe 30 lines, and the reviewer for the pull request is taken automatically from an AD group that is people who know this area of the service, and part of their job is doing the reviews. If they, over time, if they're ticking the box, it gets noticed. But the main thing to make it easy for the reviewers is they're not looking at thousands of lines of code every couple months. They're looking at a few lines many times a day. So every one is very small. And as you saw, there's a 12-hour window on the review. So the expectation is not only that your code is fresh when you submit the pull request, the expectation on the reviewer is that they respond right away. Okay, and you know, people will message each other and say, hey, I want a pull review now. I want a code review now. Go ahead.
Once you fix a bug, are you then also required to write a test for that bug to make sure that it doesn't reintroduce itself?
Are you required to write a test when you fix a bug? You are required to write a test for any code, and your definition of done is your code has tests that pass and your code is deployed in production worldwide and is collecting telemetry against the hypotheses that motivated its deployment. So you can substantiate or diminish the hypotheses that led you to do that change. So the answer is yes, and not just for bugs. And if now we do also track many forms of debt on testing. So if there is already a test covering that code path, we expect you not to write a new one. So we're continually looking for duplicate tests. You didn't see any on the dashboard I showed you, but sometimes you'll see a yellow box, which means that we found a flaky test. That is one which unreliably flips from green to red and back, in which case that triggers a bug on the test that says the test needs to be rewritten to be reliable. Jeffrey.
How do you manage the test aggregation so it fits within a time window?
How do we manage test aggregations that fits within a time window? We set a threshold on how long tests are allowed to run when. So our L0 and L1 tests, which run in the pull request, we initially set a North Star if we want them running under 10 minutes. It's now down to 7 minutes. And we set a target on L2 tests, which are the pre-production tests, of an hour. Now, we didn't get there right away. If you roll the clock back 4 years, we had a whole bunch of long-running integration tests. And we'd have, quote, nightly automation runs, quote, full automation runs, which took days or weeks, and blah, 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 blah. And the testing impedance on that was that it slowed everything down. It's also true that in 8 years of TFS having these nightly automation runs and full automation runs, we never had a single test run that was all green. There was always a failure reported, and someone always had to say, oh, let me go investigate. Let me figure out, was that really a failure of the code under test, or was that a flaky test, or what have you? So we said, this sucks. We need to fix our testing so that it can provide immediate feedback to the developers. And we went through a transformation. One of our epics is engineering improvements. And there we set some North Stars. And the North Star was how fast tests run and give feedback. And we would measure progress every sprint. And it took us about 3 years of sprints to get from a portfolio that was roughly 30,000 long-running integration tests to one that is now about 80,000 fast-running tests and very few of those long-running tests. So this wasn't magic, it wasn't overnight, it was setting a North Star and then measuring progress every sprint. Okay, and I'm going to go on in the interest of time. All right, one of the issues we had, I mentioned we're all in on Git. One of the issues we had, since we support all of Microsoft, is that Git wasn't designed for very large code bases. And we had this thing called Windows, which is a very large code base. And so there was this explosive debate a few years ago on this thread called Engineering Systems Architecture Review about how to refactor Windows so that it could be, as, in all these small little repos, blah, 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 blah. And the idea of, going through a year of refactoring with no customer deliverable, that didn't fly so well. So we took the opposite approach. We said, we'll fix Git. So we went about re-engineering Git on the model of what you see with like a photo sharing site, like OneDrive or Google Photos or something like that, where instead of downloading the file, when you see the picture, you see a thumbnail that's sort of a link to the file, and then you get progressive rendering as you go through. So it's a lazy loading model. That's called Git Virtual File System, GVFS. It's we open sourced it on GitHub. It's going into the Git community. That's what let us get Windows on Git. This was important enough that this is something that Satya championed at his monthly employee town hall. And what we did, these stats aren't quite current, they're more dramatic now, but we basically got across many things roughly a 300x performance improvement. So with Git Classic, a clone took 12 hours if it succeeded. If your laptop went to sleep, you had to start over. That was not good user experience. Now it actually is now 90 seconds. The slide's a little old. When we first came out, it was 2.5 minutes. Git status took 8 minutes. Now it's a couple seconds and so forth. So that was an example of building the engineering system to serve the org needs and contributing it back to the community. It's a great example of what we call first party equals third party. In other words, doing something that we need and then giving it back. What are the things that we measure? So the top of this, which I realize is pretty small, sorry, is a cutout from our engineering scorecard. Each row is a feature crew, and each column is one of the metrics. And the little sprint lines, the little spark lines are showing you sprint to sprint how those crews are doing on the particular metrics. They're basically 4 buckets of metrics. Live site health is everything about how good is the service right now. This will be very familiar to this crowd. How good are we at detection, mitigation, and so forth. Now, every LSI, live site incident, isn't closed until we do a root cause analysis, the goal of which is to identify what we need to do to prevent a recurrence. And that leads to these things called incident prevention items, which go on that backlog I showed you, and those need to be closed in a sprint. So one of the things that's being tracked up there is number LSI repair work items older than 2 sprints. You see those crews are all at 0. That's great. They're green. But we track that. We track customer support metrics. We track all the aging on that stuff and so forth. That's live site health. Velocity is the other direction. It's how good are we getting from changes to production? And how good are we at getting the telemetry out of them and learning and so forth? Engineering consists of governors of debt. So we want to be sure that no tech debt is building up that keeps us from achieving that single piece flow. So if you look, for example, under engineering, you'll see bug cap per engineer. If you look on the scorecard, you'll see number of P0 or P1 bugs older than 21 days. So the idea is you close bugs in the sprint, and you have a bug cap, which means if you have 10 engineers on your feature crew, you're allowed 40 active bugs in principle with a bug cap of 4. If you have more than that, you stop new work, you pay them down before you go forward. Now in practice, you'll see that the number of active bugs per engineer there is 2 or 3, so it's not a big deal. And this is a team, it's a team average. It doesn't mean per individual, it means aggregated across the team and average. You saw test pass rate and coverage on the dashboards and so forth, so I don't need to drill into that. The fourth column, which really gets to what Jeffrey advertised as the talk I'm not doing, is looking outside in. It's looking at customer usage. So we look at how good are we at acquiring new customers, how good are we at taking new customers to be engaged, how good are we at getting them to be dedicated, that is using the service day in, day out. And then we can drill down, not just to look at this in the aggregate, but to look at it from the standpoint of features. So when we roll out something new, we will do it under a feature flag, and we'll use metrics like, for this preview feature, what percentage of users are opting in to keep the new one that's currently in preview? And we will look for a threshold, like we want 95% opt-in before we take this out of preview and make it general availability. So those are the outside-in metrics that we use to build up validated learning. And that's the kind of stuff that we track. Okay, we do this because by means of a common telemetry pipeline. This is available to you externally as Azure Application Insights Analytics, one of Microsoft's typically horrendous names. Internally, we call it Project Custo. We're gathering, give you an idea, about 2 petabytes, over 2 petabytes of data daily across Azure services. And we're using that both for the hot path troubleshooting as well as the, quote, cold path usage analytics. I talked about closing LSIs with root cause analysis. If there was an outage, that gets blogged publicly. And the one on the end here is a blog from February a year ago where we were talking about what happened to us when we went to SQL 2016 and we discovered that our sprocs needed to be updated because of query plan optimization changes and memory management in the new SQL, and here's what we learned. Is this working? This is what our workspaces look like. They're called team rooms. That's a feature crew. It's not a big open space like this. It is the crew working together. Conway's law applies. So the software we ship is doomed to fit the org structure that we have, so we make the org structure fit the software we want to ship. And we put the team together. How do we get that team? We pick the leads roughly every 18 months. They stand up in a room like this and say, hey, my team is called Modern Wit, and here's what we work on, and we're the best because. And then the next one says, hey, we're doing Azure Continuous Delivery, and we're the best because, and so forth. And then the engineers write down 1, 2, 3, their first, second, third choices. We call this the yellow sticky exercise. And out of that, they pick the teams they want to work on. And everyone gets to choose where they want to work on. We do over 90% first choice. We're doing one of those right now. We use a one ES day, one engineering system day to communicate across the company. This is wildly oversubscribed, and it builds up all this content online. So as Steve mentioned in the beginning, we're now at about 75,000 active users inside Microsoft, something over that as the end of last month, and it keeps growing. I'm getting the hook. I'll be around today. I'll be happy to take more questions wherever in the lobby, coffee, whatever. So time for breakouts. Thank you.
Okay, so if you're not sticking around for the Microsoft track, if you head on downstairs, find your rooms, and you've got 2 minutes.